Okay, so in this video I'm going to have a look at the Junior Certificate Higher Level Maths Paper 1 for 2019, questions 1 and 2. So in this particular question 1 here we have 85 students in third year in Liam School. 2/5 of these students do business studies. Work out the number of these students who do not do business studies. So if 2/5 do business studies, then 3/5 do not do business studies. So if there are 85 students in third year, we just got to multiply 3/5 by 85 and we get 51. So we get 51 students who do not do business studies. That's it for part A. Part B, 26 of the students in third year do art. Work out the percentage of students in third year who do art, correct to one decimal place. So we have to get 26 as a percentage of 85. So the way you do that is you put 26 over 85 multiplied by 100, and that gives you 30.6 to one decimal place. So it's 30.6%, and that's to one decimal place. Who do art. Okay, and that's part B done. So let's have a look at part C. So in part C here we have the ratio of students to teachers in Liam School is 15 to 1. So we have 15 to 1 students to teachers. Now the student hires one extra teacher while the number of students stays the same. The new ratio of students to teachers is A to 1. So we got A to 1. Where A is an element of Q, so A is a rational number. Put a tick in the correct box to show which statement is true. Tick one box only. Give an example to support your answer. Well, what's going to happen if you increase the number of teachers by 1, the part of the ratio that represents the students will actually decrease. So A will be less than 15. So an example of that would be, let's say for example we take, we know there are more than 15 students in the school. So I mean you couldn't say for example there are 15 students and one teacher. In that particular case, if you increased the number of teachers by 1, you would get 15 to 2. So that would mean the number of students, the A would remain the same. But we know that there are 85 students in third year, so we know that this here is not possible. So we have to pick another number. So let's say there are 210. Let's say there are 210 students. So this is the number of students, and that would mean there are 14 teachers. So that will give you a ratio of 15 to 1 when you simplify it. Now if you increase the number of teachers by 1 here, you would have 210 students, and now you would have 15, so you would have 210 students, you would have 15 teachers. The ratio now becomes 14 to 1. So you can see here that the A part of the ratio that represents the teachers decreases from 15 to 14. So A will be less than 15. So this would be an example here. Okay, let's have a look at question 2 then. We have, let's see, write down the 4 factors of 45 apart from 1 and 45. So if you take, usually the way I do these things is write down 45 and then I start writing down the factors starting at 1. So 1 times 45 will give me 45. So I now have two factors here. Now we can't use these ones, but let's go to 2 then. 2 will not divide into 45, so we can't use 2. 3 will divide into 45, and you'll find that 3 times 15 will give you 45. So we have another two factors. Let's move to 4. 4 won't divide into 45, so let's move to 5. 5 will divide into 45 9 times. 6 won't divide into 45. 7 won't divide into 45. 8 won't divide into 45. The next one is actually 9, and we already have 9, so we just start repeating ourselves. So these are all the factors of 45, all the whole number factors of 45. So the numbers they're looking for here are the numbers that don't include 1 and 45. So we would be looking at 3, 5, 9 and 15. They're the numbers they're looking for here. Okay, let's look at part B then. N is a whole number bigger than 1. It has just two factors, 1 and n. Put a tick in the correct box to show what name is given to this type of number. So this type of number really is just a prime number. So it's going to be a prime number here. Any number bigger than 1 that only has two factors, 1 and itself, is called a prime number. Put a tick, so we don't have to do anything else, just put a tick in. So the correct answer there is prime. So let's look at part C then. Part C, P is a whole number apart from 1 and P. So we have a number called P here. Apart from 1 and P, the only other factor of P is 7. Work out the value of P. So if we take 7 for example, 7 is a prime number, but it's 1 times 7. So the only factors of 7 are 1 and 7, but we can't use 1 and P. We can't use 1 and 7, so we can't use 7. Let's take the next factor of 7, which would be 14. That's 2 times 7. The problem with 14 is that it has not only a factor of 7, but it also has a factor of 2. So that's no good to us either. Let's take 3 7s, which is 21. So that's 3 times 7. The problem with this is that it has a factor of 3 as well as 7, so that won't work. And you can keep going. I mean, 4 times 7, 28. So again, we have 4 times 7 here. So not only does this have a factor of 7, it also has a factor of 4. So that's no good. 5 7s, 35. So again, that's no good to us because we have 5 as a factor. 6 7s, again, that's no good because we have 6 as a factor. And then finally we come to 49, which is 7 times 7. So 49 only has two factors, 1 and 49, and the factor 7. So it has 3 factors in total, 1, 7 and 49. So the value of P then, in other words, P then is equal to 49. It has factors 1, 7 and 49. It doesn't have any other factors. So that's it. That's all we were required to do, work out the value of P. Okay, so let's have a look at D then. So we have write down the 4 factors of 12k plus 8 apart from 1 and itself. So apart from 1 and 12k plus 8. We've got to write down other factors of 12k plus 8. Well, if you take 12k plus 8 and see if you can factorize it. Well, I don't need those two brackets really. 12k plus 8, how can I write that another way? Well, let's look for common denominators here between 12k and 8. Well, one factor would be 2, so we could do this kind of thing here, 6k plus 4. So now we have two factors of 12k plus 8. We have 2 is a factor and 6k plus 4 is a factor. Let's see what else we could do. Well, we could also divide both by 4, so we could take 4 out, so that would give us 3k plus 2. Now we have all our factors here that we only need 4. 2, 6k plus 4, 4 and 3k plus 2. So we can write those in. So 2 is a factor, 4 is a factor, 6k plus 4 is a factor, and 3k plus 2 is a factor. And that is it, I think, for this question. Yep, no more to it. Okay.